All right, in Concept C, we're going to now focus on covalent bonding. We're going to talk about what covalent bonding is and then some different types of compounds that contain covalent bonds. So covalent bonding occurs between two nonmetal atoms. We've already talked about ionic and metallic, which involve metals. They attempt to gain each other's valence electrons. However, since they don't have a big enough difference in electronegativity values, they're not actually able to transfer electrons. They simply have to share them. So in general, if your electronegativity difference is at or below 1.7, the atom with the higher electronegativity does not have enough pull to remove the other atom's electrons. So that's why they end up sharing them. Now, we will see that when they're shared unequally, we'll see that we kind of get this kind of partial charge that forms because the electrons will spend a little bit more time around the atom with the higher electronegativity, but they're still going to have to share them because they don't have a big enough difference in electronegativity values. Now, the bonded atoms usually become part of each other because of how they're sharing these electrons. Now, this makes for then a much stronger bond than in the ionic bond that we talked about in Concept B. Now, depending on the number of electrons shared between the two atoms, we can have a single covalent bond, a double, or a triple covalent bond. So we're going to just quickly talk about each of those. Single covalent bond, which is represented by a single line or dash, involves two electrons shared, or we can say one pair of electrons. So we can represent that by either two dots or by a line between the two elements. And again, this dash represents the two electrons shared. A double covalent bond is indicated by two lines or dashes, and for every line that means two electrons. So two lines gives us four electrons shared, or we could say two pairs of electrons. So you want to make sure you're differentiating in questions. Are they asking for the number of electrons or pairs of electrons? And you can see that double bond is representing these four electrons shared between carbon and oxygen. A triple covalent bond, which a common one is N2, involves 6 electrons shared, so 3 pairs of electrons. So you can see here that each nitrogen needs a total of 8 electrons around it, so they actually have to share 6 electrons between them, which is represented by 3 lines. So that's an example of a triple covalent bond. We'll get into how to figure out if you have a single, double, or triple bond in the next concept. Now we're going to talk about a couple of different types of compounds that you need to know that contain covalent bonds. The most common that we're going to be working with for the basically majority of this unit are molecular compounds or molecules. These consist of individual molecules that only contain covalent bonds. So when we talked about ionic bonds, we talked about a crystal lattice. Here we're talking about individual molecules. So each molecule of a substance has an identical molecular formula that tells you exactly how many atoms there are found in the molecule. You need to know the properties of these molecular compounds. In Concept B, we talked about ionic compounds and their properties. For our molecular compounds, these tend to have low to medium melting points and boiling points, depending on the polarity that we'll talk about in a later topic. They're non-electrolytes, so they do not conduct electricity. There's no charges present, so there's no way it can conduct. And they tend to be soft materials. Another type of compound that contains a covalent bond is a network solid. These contain three-dimensional covalent bonds, usually involving carbon or silicon. So a very common example, which is a component of sand, is silicon dioxide, so SiO2. Also, we originally talked about this as allotropes, but they're also types of network solids are diamond and graphite. So they have multiple covalent bonds involved that make them create very strong covalent bonds and a very strong structure, which leads to the following properties. They have extremely high boiling and melting points. They tend to be very hard, with the exception of graphite because of how the carbons are arranged. They tend to not conduct electricity, except for graphite, again, having to do with how the atoms are arranged in sheets, and they do not dissolve. The big thing I want you to remember is the extremely high boiling and melting points of our network solids. Again, here you can see on the left we have the graphite, so we have sheets of carbon atoms, and then over on the right you have silicon dioxide, where you can see we don't have individual molecules like in our molecular compounds, but these continuous covalent bonds. Another type is a coordinate covalent compound. This is formed when both of the shared electrons come from the same atom. Usually each atom is sharing at least one of their electrons in a bond. Here, they're both coming from the same one. So we start with a hydrogen ion, which contains 0 electrons. We have ammonia, which is NH3, and you can see that we have these 2 lone pair electrons sitting on nitrogen. And what happens is that hydrogen, the positive hydrogen atom, is going to be attracted to the 2 negative electrons in this orbital. So they go and form the ammonium ion, where both of these electrons have come from the nitrogen and hydrogen has not contributed any of them to the ion. So that's an example of a coordinate covalent compound. We'll go through a couple more tomorrow in class. Finally, I just want to mention polyatomic ions. Polyatomic ions themselves have covalent bonds. Within the polyatomic ion, they're sharing electrons. However, that creates, because of how the polyatomic ion is formed, creates a charged particle or charged ion. Because of the charge, it's going to then form an ionic bond between the polyatomic ion and either another polyatomic ion or a metal or even a nonmetal. So polyatomic ions themselves contain covalent bonds. However, a compound containing a polyatomic ion contains both covalent and ionic. It's a very common question where it'll ask you to locate the compound that has both ionic and covalent bonds. So you want to be able to check table E and find that polyatomic ion, and that's your compound that will have both types of bonds. All right, tomorrow we'll actually get into how to draw these types of molecular compounds and go a little bit more into covalent bonding.